For this lesson, we want to discuss evaluating an expression. So if we're given an expression like 2x plus 1, we can plug numbers in place of x and reduce it to one value. That's to evaluate it. So here I want to evaluate it for x is equal to 1. I'm just choosing that value at random. So what that means is you take your expression, put some parentheses around the x, put 1 in place of it. We have 2 times 1 plus 1. This is 2 plus 1, or 3. And you can do this for any value that you'd like, so I guess I could also try it for negative 0.5, but the idea is the same. We have 2 times negative 0.5 plus 1. This is negative 1 plus 1, and this simplifies to 0. So depending on the number that you're given, it'll just reduce to a different number. So for example 1, I want to look at maybe some slightly more complicated expressions, but the idea is exactly the same. So for 2x squared plus 3x minus 1, I want to evaluate this for x is equal to negative 3. So again, to do that, I'll take the expression, and anytime I see parentheses, I'll enter in negative 3. So that's 2 times negative 3 squared plus 3 times negative 3 minus 1. So following our order of operation, let's see, we have 2. I'll deal with the exponent. If we square negative 3, that's 9. Now I'll multiply, so 3 times negative 3 is negative 9, and then we have minus 1. So this is 18 minus 9 minus 1, and this becomes, this is 9 minus 1, or 8. For part B, let's see, now we have two variables in here. So there's both y's and x's, and we're given x is equal to negative 1 and y is equal to negative 6. So to evaluate this expression, we need these two given values. So let's see, what I'll do is, we have y over 2, so that's going to be negative 6 over 2, plus, okay, now we have negative 6 squared over 2, and then plus 2 times, all right, now we come to x, so I'll put negative 1 in place of x, and I'll put negative 6 in place of y. So here I've plugged my two values into the corresponding variables, and I'll just simplify it in a really similar way. So let's see, negative 6 divided by 2 is a negative 3. For the next piece, okay, 6 squared is 36. It's going to be positive, so positive 36 over 2. And for the last term, there are two negatives, so I know the whole thing is going to be positive. 2 times 1 times 6 is 12. So to complete this, we have negative 3 plus 18 plus 12. And I can do those all at once. That is going to be a positive 27. And that is it for example 1. For example 2, here we're going to use this concept of evaluating expression, but we're going to use it within an equation. So here we're given that the area of a circle is given by the equation a is equal to pi r squared. So maybe just to draw a picture off to the side. If this is a circle, the radius starts from the center and goes out to the edge. We call this r, and I'll just copy down the formula again. If you take the number pi and you multiply that by whatever the radius is squared, that value is the area. That's how much space this circle occupies. For pi, I'm going to use 3.14. This is a very good approximation, so I'll just replace it in my formula. A is equal to 3.14 times r squared. So let's see, the first part of this question says that if the radius is 4 feet, what is the area of the circle? And this is just a matter of going to your equation, and wherever you see the radius, you place the value 4. I'm also going to put the value feet within the parentheses too. So here it is. The area is 3.14 times 4 feet squared. I'll simplify this. Okay, well, 4 squared is 16, and I'm going to multiply that by 3.14. So 3.14 times 16 is 50.24. So I'm just doing this right on a calculator. But you do get something else. You're also squaring feet. So if you have feet times feet, I'm going to write that as feet squared, which makes sense. A distance is feet. So this could be like 1 foot. But if you want to have a unit of measurement for area, you'd go a foot at a right angle to your first one. And this square represents 1 square foot. So for this particular circle that we have, I'm saying there's 50.24 of these square feet. Now the second part of this question says, if we take the radius, we started with 4 feet, but let's say we were to double it to 8 feet. Does the area of the circle also double? To analyze this, we can go back to the same formula, and we'll just do the math again, but instead of saying a total of 4 feet, I'll just put the number 8 in instead, and then we'll compare the two answers that we have side by side. So, okay, if we're checking 8 feet, it'll be 3.14, but now it's going to be times 8 feet squared. And on a calculator, I'm going to do this next part. So 3.14 times, and we have 8 times 8 is 64. So this is 200.96 this time. And the units are still feet times feet, which we'll just call square feet. So, okay, when we had a radius of 4, it was 50.24. When we had a radius of 8, it was 200.96. So it definitely did not double. I mean, I can clearly see it's more than double, right? Like if you multiply this number by 2, it just puts you over 100, but this is 200. In fact, it kind of looks like it quadrupled. It multiplied by 4. And to just verify that, if you take 50.24 and you were to multiply it by 4, you do in fact get 200.96. So if you actually double the radius, the area of the circle quadruples in size. And to go back to the formula really quick, that kind of makes sense. So if you put the value 2 into the radius, like if you double something, but then you square it, 2 squared becomes 4. That's why it increased by a factor of 4 this time. But that is it for example 2.